All right, so welcome to yet another section of quantitative methods. Please, if this happens to be your first time of joining this series on quantitative methods, kindly subscribe to the YouTube channel for more content. Actually, it will help you get a notification. So we want you to be the first person to see our content once a video is being uploaded. So please kindly click the red subscribe button at the down right corner to subscribe. Okay. All right. So in this session, I'll be taking you through what we call probability distributions. Probability distributions. So in this section, I'll be doing this section in two parts. I'll be doing probability distributions part 1, and I'll be doing probability distributions part 2. Okay, so before we enter into the concept of probability distributions, I would like us to understand certain basic terms. Now, when we talk about a random variable is a variable whose value is a numerical outcome of a random phenomenon. So a random variable is a variable whose value is a numerical outcome of a random phenomenon. Okay, so here, if I want to make investment in stocks, or if I want to make investment in shares, the returns I'll get on the investment in shares is very uncertain. Unlike bonds or loans, if you want to make investment in debt instruments, for instance, if you want to invest in 5% debenture, you know that at the end of the day, you get 5% on the amount you invested. But once you are investing in shares, it is sometimes difficult to determine the exact amount of return you get on the shares. So here, any variable whose value is a numerical outcome of a random phenomenon is termed as a random variable. So for instance, the returns you get in investing on shares, or the returns you get in investing in shares, that returns can be referred to as a random variable. Okay, so for instance, the return you can earn on an investment in stocks is a random variable. All right, because as I mentioned, a random variable is a variable whose value is a numerical outcome of a random phenomenon. Okay, so the returns that we get on shares, that outcome is very random. You can't tell with certainty. Reason being that the return on shares consists of two things. Number one, the capital appreciation, where we cannot predict with certainty in terms of how much the share price will appreciate. We can't predict in terms of certainty. And another one is the dividend that you are being paid on the shares. And that one definitely depends on the market scenario, or it depends on how much profit the firm has made. Okay, so the return on shares is an example of a random variable. Now, because we are assessing the likelihood of getting certain returns, or because we are assessing the likelihood or the extent to which we can get certain returns, the returns themselves and then the likelihood with which we can get the returns can be used to draw a probability distribution. So for instance, let's look at this scenario. So for instance, let's assume that you are investing in asset X, okay, or shares of company X. Now, it can happen that you can get 10% return. It can happen that you can get 6% return on your shares. It can happen that you can get 8% return on your shares. It can happen that you can even get 15% returns on your shares. Now, let's assume that here we have computed the probabilities, and we know that the likelihood that you get 10% return is, let's say, 40%, or 0.4 probability. 0.40 probability. Then the likelihood that you get 6% returns is, let's say, 0.20. The likelihood that you get 8% return, or the probability that you get the 8% return is, let's say, 0.30. And the likelihood that you get the 15% return is 0.10. Essentially, all probabilities should sum up to 1. So that is why here, if you sum all the probabilities, you get 1. Now, given this information, you may be able to use this to draw a distribution. So we can plot probabilities on the y-axis, and we plot the returns on the x-axis. Okay. So for instance, if we are plotting probabilities on the y-axis, we can do a scale of 2 centimeters is to 0.1 probability. So here we have 0.10. Here we have 0.20. Here we have 0.30. Here we can have 0.40. And we can even have 0.50. So for instance, the probability of getting a 10% return, or 0.40. So we can draw a distribution for that. So we have 0.40. All right, so the probability of getting a 6% return was, so I can plot 6% here as a return, and then I can just plot it at 0.20. Then let's say the probability of getting 8% return here is 0.30, so I can plot it here. All right, then probability of getting 15% return is 0.10. 0.10, 15% return. Please don't worry if on the x-axis these figures are they are not following. Essentially, I'm treating this phenomenon as a bar graph. So these figures here do not need to follow per se, but the emphasis is on the probability distribution. So this is a clear example of a probability distribution. Now, here, there are several methods, or there are several formulas which enables us to assign probability to each possible value of a random variable. So there are tables and there are formulas which helps us to do that. Now, if we have a probability distribution, we could compute the expected values from a probability distribution. Now, when we talk about expected values, it is the value that you expect to get if the trials were repeated infinite number of times. So if the trials, or let's say if the investment you make is repeated in infinite number of times, okay, the value you expect to get is what we call the expected value. In essence, the expected value can be thought of as the mean, okay, and this dispersion can be thought of as the standard deviation. So if we have the frequencies, remember that probabilities are computed by number of favorable outcome over number of successful outcomes. In essence, every probability or every probability figure have been computed using the total frequency and then the frequency of a particular class. Okay, so that is how we come about computing probability values. In essence, Once you multiply the probability values by the returns, you should be able to get the average, because the probability values have been calculated as relative frequencies. The probability values have been calculated as relative frequencies. So once you multiply the probability values by the return, you should be able to get the average return, which is also referred to as the expected return, So expected values is the value you get if the trials are repeated infinite number of times. And that values is just an average. And the average is just found by multiplying the probabilities by the returns, and you get the expected return. Okay, and the dispersion around that expected return is the standard deviation, which is also a measure of risk. Okay, now this concept is usually applied to investment. So for instance, this concept of probability distribution will help us to calculate the expected return or the mean return for our investment. Okay, so it is usually the case that uncertainty cannot be eliminated. So if you are making investment, uncertainty cannot be eliminated. Now, therefore, we must recognize and incorporate the issue of uncertainty in our decision making. And the only way we can incorporate it in terms of decision making when it comes to investment is to find the expected return on our investment. So we can inculcate or we can incorporate the idea of uncertainty by measuring the uncertainty with probabilities. And once we multiply the probabilities with its associated return, and once we sum it up, we are going to get the expected return. All right, so once we incorporate the idea of probabilities in terms of our investment, then those probabilities can be thought of as the uncertainty surrounding our investment. So in simple terms, if we want to calculate the returns that we should expect on our investment, we simply multiply the probabilities by its associated return. So if let's say we have a return like 8%, what is the likelihood that we get that 8%? That likelihood is measured in terms of probabilities. So all the returns, all the various returns, as well as their associated probabilities, when you multiply them and you sum it up, you should get the expected value. So the expected value is also referred to as the expectation. Now, here, if X is so application of probability to investment. If X is a random variable and takes on the value Xi with probability Xi, then the expected value of X is obtained by multiplying each value that the random variable can assume by its probability and summing these things up. So these things is just like a weighted average of the possible outcomes, okay? All right, so I think I mentioned this already. Now let's look at this example. Foriwa is considering 3 investments with the returns and the various market conditions shown below. Now, if the market is in a boom, asset A will get 15% return, recession 4.5% return, depression 1.3 return, normal 5% return, okay? And then if it's in a boom for asset B, 20% return, recession asset B 3%, depression asset B 1.7%, and normal 9.2% for asset B. Now the data from the stock market indicates that the likelihood that the investors will invest during a boom is 40%, and that of recession is 20%. The data further indicates that the probability that the investors will invest during a depression and the probability that the investors will invest during a normal period are the same, okay? So I already mentioned that all probabilities must sum up to 1. So in essence, if we want to find the probability associated with the boom, the question said is 40%. That of recession is 20%. That means that when you sum the 40% and 20%, you are going to get 60% probability or 0.6. That means that the remainder, which is 0.4, is for depression and then for the normal period. But the question says that the probability for depression and normal are the same. So if 0.4 probability is left, okay, and if the probability for depression and normal are the same, you just divide the 0.4 by 2. So in essence, the probabilities, boom will have 0.40, recession will have 0.20, then the remainder of 0.40 is shared between depression and normal. So we have 0.20, 0.20, so that everything will sum up to 1. So the question says that we should compute the expected return and risk of each investment. B, advise the investor on the investment she should invest in if the investments are mutually exclusive. Okay. Now, I already told you that the expected return is simply the summation of the various probabilities multiplied by the associated returns. Okay. So the expected return on asset A, the first probability was 0.40. Its associated return is 15. The second probability is 0.20. Its associated return is 4.5. The third probability is 0.20. Its associated return is 1.3. Then the final probability was 0.20. Its associated return is 5. And that is for asset A. When you multiply this and you sum it up, you are going to get 8.16%. If you do same for asset B, the first probability was 0.40. Its first associated return, which is associated with the 0.40 probability, is 20. The second probability is 0.20, which is associated with a return of 3. The third probability is 0.20, which is associated with a return of 1.7. And the fourth probability is 0.20, which is associated with a return of 9.2. Okay. So once we sum this up, we are going to get 10.78%. Okay, and these are the expected return on asset A and expected return on asset B. All right. So here, if we want to know the risk is standard deviation, and it is computed by this formula. So we find the square root of the variance, where the variance is the probability into brackets. So we have the probability into brackets, the various returns minus the expected return, bracket close, squared. So if you want to find the variance for asset A, it will simply be the first probability, which is 0.40 into bracket. The first return for asset A was 15. Its expected return was 8.16. Then you square it. So plus, because of the summation, the second probability was 0.20. Then the first return associated with the probability of 0.20 was 4.5. You subtract the expected return, which is 8.16, plus, so squared, sorry, plus the next probability is 0.20. Then the return is 1.3. Then the expected return, which is constant throughout, as we can see, is 8.16. Then you square it. Then finally, we can now add so plus 0.20. The last return is 5 minus the expected return, which is 8.16. Then we square it. So once you do this, you are going to get 32.8023. Then so this is the variance. Once you want to find standard deviation, you find the square root. So the standard deviation is the square root of 32.8023. Then you get your standard deviation. So let's apply the same idea and solve that for investment B as well. So you can either do this horizontal approach, or like what I've done here, or you can do the tabular form, which is here. It's essentially the same thing. You should get the same answer. All right, so we have the risk. So here, going back, you should get square root of 32.8023 is 5.727. And if you do that for asset B, you get the variance to be 63.0977. When you find square root, you are going to get a standard deviation of 7.943. So that is how we compute expected risk and return using probabilities. Okay. So in essence, we started by explaining what a probability distribution is, and then we explained how we can apply that concept in computing expected risk and return. And for quantitative methods in business decision, the emphasis here will be on just to know how to compute the expected return and risk of each investment. So drawing the probability distribution for returns for now is not important, but you should master, or the takeaway here is that you should know how to compute expected risk and return of investment, but by applying the expected return formula and applying the risk formula to compute it. Now, the requirement of the question says that advise the investor on the investment she should make if the investments are mutually exclusive. Now, when events are mutually exclusive, what it simply means is that we can, or what it simply means is that the two of them cannot happen at the same time. So here, if you want to invest in these two assets, asset A and B are mutually exclusive, what it means is that you have to select one of them. Now, the bigger question here is that do we select it based on risk or do we select it based on return? Now, for some assets, if you compare, asset A has a lesser return as compared to asset B. And in terms of risk, asset A has a lesser risk as compared to asset B. So here we cannot tell directly which asset you should choose, because for asset A, the return is less and the risk is less. For asset B, the return is higher and the risk is higher. So in other words, we have to do what we call a relative analysis. And the relative analysis is finding the percentage of the expectation, or finding the percentage of return that is risk. And that idea is referred to as coefficient of variation. Okay. So for asset A, the risk was 5.727. The expectation or the expected return was 8.16. So if you find a percentage, you get 70.18. So it means that 70.18% of the return of asset A is risky. Okay. Then for asset B, you do the same, you apply the same concept. Then here you get 73.68, which simply means that 73.68% of the return, the expected return of asset B is risky. Now, in doing this, it means that we select asset A because it has the least coefficient of variation, or it has the least relative risk. Okay. So that is the concept of risk and return by applying the idea of probabilities. All right, by applying the idea of probabilities. Okay, so this is the first aspect of the probability distribution. Please, as I said, we want you to be the first person to see our videos when it's posted. So please, to help our content and the promotion of our content, kindly subscribe to our YouTube channel for more content, and also to be the first person to see our video once we upload it. All right. So thank you very much for staying with us, and we will meet soon in the next video where I share taught on specific probability distributions, where I'll be talking about the discrete probability distribution. Specifically, I'm talking about the binomial distribution and then the Poisson distribution. Then afterwards, I'll talk about the continuous probability distribution, where I'll emphasize the normal distribution. So meet you soon on or in our video on the specific probability distributions. Thank you for subscribing to our channel, and thank you for patronizing our content. See you soon.